All right, let's look at the cross product we talked about in class. And if you try to see what we have in class is the following. We have two vectors, A and B, and we know now how to calculate its cross product. And these are the formulas we explained in class. And try to recall when we were talking about the dot product, and we also had a different interpretation, so-called the physics interpretation of the dot product. So we actually had the following. So we have A vector dot B vector, and this is equal to A vector's magnitude and B vector's magnitude and cosine theta. And this theta over here is the angle between A and B. Okay. So this is the meaning of this dot product. And we actually also have a similar meaning for the cross product. And here is the explanation. So if you look at the cross product and look at the magnitude of this vector, not just the vector itself, then it's equal to the magnitude of A times the magnitude of B and times sine theta. And that, if you look at this one, it's almost like the counterpart of the dot product. Just remember, on the left-hand side, we have a number, so we have the this absolute value. Now, there is an interpretation of this expression on the right-hand side. This one over here is precisely the area of the parallelogram spanned by these two vectors. So if you have A over here, is A vector, and you have another vector, say B over here, okay? And then this value over here is exactly the area of this parallelogram. And how do you do that? You just say, oh, we put it over here, and this is the one. So this area A, is exactly the magnitude of A times the magnitude of B and times sine theta. So now we also have a physics definition for the cross product. So cross product, actually it works also for vectors in 2D if you think that the z direction is simply 0. So you have, first of all, you need to have a value. So this one over here is magnitude, the length over here, the magnitude, this vector, is equal to this area spanned by these two vectors. So this is number one, its magnitude. Then we just need to look at the definition of the direction. So its direction over here, direction, you follow use the right-hand rule. Right-hand rule. And how do you use the right-hand rule? Imagine if you have vectors like this. You say you have A vector over here and it's B vector over here, right? And you try to curl your fingers from A to B. So you go over here, your 4 fingers, you curl this way, and then the direction of your thumb points to the direction of this A cross B. But you have to imagine this is in dimension 3. So if you think about that, this direction is going to come out of this screen. So this is the direction. Okay. And sometimes in physics we use this one. So the direction of A cross B is an arrow coming out of the screen. And if you have, say, A over here and B over here, like this, then if you use the, it's the same thing. If you look at it from A to B, okay, you curl your 4 fingers this way, and then your thumb is going to point from inside out. So this is the same thing, you can see. But if you have A on this side and B on this side, and then if you curl your 4 fingers this way, then the direction goes inside the screen, and we use a cross inside a circle. So this is the direction of this vector A cross B. And that's why you can also explain that if you swap the position of B and A, then you get a negative of the original vector. So we know if you have a direction and also have a magnitude, then this vector is completely determined. So we also know that this cross product can be defined using physical way instead of a mathematical way. And if you look at this definition over here, then again, you can say, well, once we have this definition, we can actually do the cross product of any two vectors. It doesn't matter if what dimension is. But if you think about it, we are only talking about three vectors. So still, we are really having just a dimension 3 space. A vector, B vector, and then A cross B vector. Of course, the most useful thing over here is that now we have, if you have two vectors, A and B, that this one over here is going to be perpendicular to A and also perpendicular to B. So this is number one useful computation. And second one is the area. A cross B over here, the magnitude is the area of the parallelogram spanned by these two vectors. So these two properties are the most useful ones. Okay, let's finish this episode at this point.